Hey guys, welcome to question MM339 of the Maths Methods Fortify study guide. So, in this question, we have Agnes, who is replanting her herb garden, and it's bound by 3 garden paths. Her northern garden path is modeled by the function f of x equals ax cubed plus bx squared plus cx plus 3, which is this function here. The x and y axes represent the other paths around her garden, as shown in the diagram below, so just here. Awesome. It's also known that f dash of 0 equals negative 3, f dash of 1 equals 0, and f dash of 3 equals 0 as well. Now part A is a 1 mark question and says show that a equals negative 1/3, b equals 2, and c equals negative 3. Awesome. So if you're not too sure where to start with this, just go with what you know. Like, just go with this first piece of information first and then work from there. So if we know that f dash of 0 equals negative 3, then we're going to be able to find our derivative function and sub that in to try and find something. So f dash of x is the derivative of this, which is 3ax squared plus 2bx plus c. Awesome. Now we know that f dash of 0 equals negative 3, so therefore negative 3 equals 3a times 0 squared plus 2b times 0 plus c, 0 plus 0 plus c, therefore c equals negative 3 as required, right? So that's part of the question. So the question said show that c equals negative 3. We've done that just with that one piece of information there. Awesome. Let's move on. So now we need to move on to A and B. So let's just take these now next 2 bits of information and we can do exactly what we just did with that one. So f dash of 1 equals 0. So therefore 0 is equal to 3a times 1 squared plus 2b times 1 plus c, and in this case c is negative 3, so we can say take away 3. Awesome. So from here we can say that 0 is equal to 3a plus 2b minus 3, and then we can rearrange this to get a equals 3 take 2b over 3. Now, we've got a in terms of b here, and we're going to need to find a in terms of b with another equation, with another simultaneous equation. So what we're going to do is find that. And we've still got this other piece of information that we haven't used yet, so we can actually do that as well. So we can say that f dash of 3 equals 0, so therefore 0 is equal to 3a outside of 3 squared plus 2b outside of 3 minus 3, which gives us 9a plus 2b minus 1. Alright, so, you know what, let's just take that back a step. So we get 27a plus 6b take 3. We can divide all that by 3, which means we get 9a plus 2b minus 1. Awesome. Now, what we want to do is get a in terms of b again, right? Because we had that before, which I just rubbed out, which I shouldn't have. A equals 3 take 2b on 3. It's our first equation. And we want to create another equation like this so that we can equate them. From here, we can rearrange this whole thing to get a equals 1 take 2b over 9, which is our second equation. Now, we can see that both of these are equal to a, which means we can actually equate them and say, therefore, 1 take 2b over 9, so this a equals this a. 3 take 2b over 3. Sweet. Now we can actually just find what b is, right? Because b is just a constant in here. We don't have any other letters, so we can do that. So we're going to times this side by 3, so we get 3 take 6b, and then we're going to times this side by 9, so we get 27 take 18b. Now we can just rearrange this. We get 12b equals 24, so then b equals 2 as required. So we've found that c equals negative 3, we found that b equals 2, and now we want to find a. So a is, we know, equal to one of these ones, so I'm just going to take this for example. So a equals 1 take 2b over 9, so 1 take 2 outside of 2 over 9, which is 1 take 4, which is negative 3 over 9, which is negative 1 over 3, as required. So I know this is a lot of work for 1 mark. You can do this in your calculator partly, but that's just how it is. So that's part A done. Let's move on to part B. So part B is a 2 mark question. And says, find the average value of f over the interval 0 to q, correct to 2 decimal places. Awesome. So first of all, we actually need to find what Q is, because we're not going to be able to find the average value if you don't know what Q is. So we know that f of x is equal to negative 1/3 x cubed plus 2x squared take 3x plus 3, because we just found that. And it actually tells us that in part A as well, so we don't actually really need to find it. So Q occurs at our x-intercept, right? So that's when our y value is equal to 0. So 0 equals negative 1/3 x cubed plus 2x squared take 3x plus 3. And then we can use our CAS to solve this. And therefore x is equal to 4.426, or Q is equal to 4.426. So that's our first mark, finding out what Q is. Now, how do we find average value? We use our average value formula. So average value is equal to 1 over b minus a times the integral of a to b of f of x dx. So 1 over 4.426 minus 0, because that x value there is 0, multiplied by 0 to 4.426 of f of x, which is 1/3 x cubed plus 2x squared take 3x plus 3. Awesome. And then we can chuck this in our calculator, and what happens is we get our average value of 2.20, which is correct to 2 decimal places as required, and that's our final answer. That's our second mark, and that's it for part B. So guys, let's move on to part C. Part C says, currently her herb garden is full of coriander. Now, Agnes has realised, as most people would, that coriander is the spawn of the devil, so wants to destroy it with coriander kill. Part C asks, she needs at least 100 milliliters of coriander kill per square meter of garden to effectively remove the coriander from the face of the earth. What is the minimum amount of coriander kill she needs to use in order to destroy all of the coriander? Give your answer to the nearest milliliter. All right, awesome. So we know that she's going to need 100 mils per square meter. So to find that total volume, all we need to do is find the total area and then multiply that by 100 mils. Awesome. So in order to do that, we're going to need to find this total area, right? So all the area under this graph. The way that we do that is by using our integral, right? So area from 0 to 4.426, negative 1/3 x cubed plus 2x squared, take 3x plus 3 dx. Awesome. Cool. So now we can just evaluate this as normal. And what we end up with is the integral, which is x to the power of 4 over 12 plus 2x cubed over 3 minus 3x squared over 2 plus 3x from 0 to 4.426. Awesome. So then we can evaluate that and sub in our values. So we get negative 4.426 to the power of 4 over 12 plus 2 times 4.426 cubed over 3 minus 3. 4.426 squared over 2 plus 3 times 4.426. And then we can minus all of these with 0 subbed in, which is simply 0. Awesome. So what does this get us? It results in 9.717 meters squared. So that's our first mark. So part of this was finding the area, but we need to find out our total volume of coriander kill that we need, right? So we need 100 mils per square meter. So to find our volume, we can just do our square meterage multiplied by 100 mils, which is going to be 972 milliliters. This is our second and final mark for this question, and guys, that's it. And you need to just make sure that you include your units as well, because otherwise it'll be wrong. And that's it. So guys, let's move on to part D. Part D is a 2-mark question again, and we're dealing with some more area now. Just give me 2 secs. I don't know why this isn't popping off now. Alrighty, awesome. So, it says, once she's removed the coriander, Agnes builds a fence through her garden at x equals a, from A to B perpendicular to the path OQ so that she can create two sections of garden. So section 1 and section 2. She will plant basil in one section and oregano in the other. Find the value of A such that she can plant the same amount of basil as oregano, and find the length of fence that is required to make this happen. Give your answers correct to 2 decimal places. Awesome. So when we talk about the same amount of basil as oregano, what we're really talking about is having the same area on either side of these two. Now we know that no matter where this fence is, the total area of the garden is going to be 9.717 meters squared, right? We found that out in the previous part. So area equals 9.717 meters squared, which means that half of that is going to be half of 9.717, which is 4.86, right? So our area is 4.86, and we need to find the value of A right here, okay? So we know that the area from 0 to A is going to be 4.86 of negative 1 over 3x cubed plus 2x squared, take 3x plus 3 dx, right? So now we can solve that in our CAS. And what we get is A equals 2.34 and A equals 5.60. And now because our Q value here is actually 4.426, this cannot be right? Because otherwise it would be down here somewhere. So A equals 2.34 has to be correct, which means that A equals 2.34. Awesome. So then from here, we actually need to state the length of fence that is required to make this happen. So in order to find the length of fence is just going to simply be our y value. So that's going to be f of 2.34, which is equal to 2.66. Sorry guys, my marker's running out. 2.66 meters, okay? So don't forget your units there. So our first mark is when we find our value of A, and our second mark is when we state the length of the fence that's required to make that happen. Awesome, that's it for part D, guys. Let's move on to part E. Now part EI is another 1 mark question, but quite straightforward. So let's work through it. So EI is 1 mark. Alrighty, so on this fence, Agnes paints a mural. On a panel of fence 1 meter wide and 2.5 meters high, the mural is represented by the shaded area below. Awesome. So part E says the bottom of the mural starts 60 centimeters above the ground, and the top of the mural is modeled by the function y equals a x take b squared plus c. So actually, you know what, let's just quickly rub this out. We don't need this anymore. So we've got our mural here, which is something like this. From 0 to 2, 1, 2. This is 1/2, and this is 1. Awesome. So we've got this mural, and we know that it is y equals a x take b squared plus c. Awesome. Now, given that the graph passes through 1/2 and 1/2, 3 on 2, show that a equals 2, b equals 1/2, and c equals 3 on 2. Awesome. So first things first is to recognize that if it passes through 1/2, 3 on 2, that means that it's going to be at our turning point, right? Because if it is at 0, 2 and 1, 2, that means that 1/2 is halfway between these two symmetrical places, which means that's going to be our turning point, right? So that means that our turning point occurs at 1 on 2, 3 on 2. So that means that if it's in this form, then we can easily say that y is equal to a x minus 1/2 squared plus 3 on 2. Okay? So we can figure that out straight away. Now, it also tells us that these are the 2 points that it goes through, right? So we can sub in either one of these points to find what a is. So let's just sub in 0, 2, because that's probably going to be easier. So that means we get 2 equals a. It's out of 0 minus 1/2 squared plus 3 on 2, which means we get negative 1/2 squared is 1/4, so 1/4 a plus 3 on 2, 2, which means we get 1/2 equals 1/4 a, and then from here we can say that a is equal to 2. Awesome. And that's it. So all of that section there is just the 1 mark, and that's it. Let's move on to part EII. Part EII is 2 marks. Awesome. And it says, how many square meters of paint will Agnes need to complete this mural? Awesome. So we're just looking for this shaded area here. Now, the area is going to be equal to the area under the graph of f of x, under y, minus this empty bit at the bottom here, which is going to be, let's just call it a rectangle. Now, how do we find the area under this graph? Just by doing our integral, right? So our integration from 0 to 1 of 2 outside of x minus 1/2 squared plus 3 on 2 dx. So that's going to give us all this area here, but we don't want all of it. We want to minus this little area under here because that's not painted, so we're not going to need that, which means that we're minusing rectangle, which is length times width, so 1 multiplied by the height here. And the question says that the mural starts 60 centimeters above the bottom of the fence, which means we're multiplying it by 0.6. Okay, because remember, everything here is in meters. This is our first mark. So getting that formula all ready and nice for ourselves is our first one. And then from here, we can simply just actually evaluate this. So we end up with 2x cubed on 3 minus x squared plus 2x from 0 to 1. Minus 3 on 5. I've just changed that to a fraction just to make it nice and clean. And then from here we can sub in our value of 1 and 0. So we get 2 outside of 1 cubed on 3 minus 1 squared plus 2 outside of 1. And then all of these with 0 in them just means 0. So minus 0 and then minus 3 on 5 at the end here. This all works out to 16 on 15 meters squared of paint. Awesome. So that's our second and final mark for part EII. If you have any questions, as always, let me know, but let's move straight on to part F. So part F is a 2-mark question. And it says, Agnes wants to put another garden path in her yard to create another section of garden. It's up here. She's thinking of building it from point P to R such that the path PR is a tangent to the graph of F at point R as shown below. Awesome. Find the exact area of the shaded region. Cool. So first things first is to figure out what the equation of this tangent actually is. Because we're not going to be able to figure out this equation if we don't know what this line is. So we're not going to be able to figure out this area if we don't know what this equation is. So that's our first thing, is to find the equation of that tangent. Now, the first thing to finding a tangent is finding the gradient of that tangent. So we're going to say that R occurs at R, f of R. Cool, so we're just going to call x equal R here. Now, f dash of x is equal to negative x squared plus 4x take 3. Because f of x is this with all of our other kind of parts put in, a, b, and c. Which means that f dash of r is equal to negative r cubed plus 4r take 3. And the gradient at this point of the tangent is the same as the gradient from P to R, right? So that means that our gradient between these 2 points, rise over run, is equal to the gradient at that point, so f dash of R, right? Now, we know that our first y value here, we're going to call f of R. Actually, you know what, we'll call it at P. So this is going to be our first point, and this is going to be our second point. So our first point is P. Now we know that this occurs at 0, 3 because of this little 3 here, right? Regardless of what all this is, our P value is going to occur at 3. So our first y value is 3. Then we're going to minus our y value with f of r, right? So f of r is going to be equal to negative 1/3 r cubed plus 2r squared take 3r plus 3 over our first x value, which is 0, and our second x value, which is r, so 0 minus r. Now, that is equal to f dash of r, which is equal to negative r cubed plus 4r minus 3. Awesome. Now we can rearrange all of this And this whole thing here becomes negative r squared over 3 plus 2r take 3. That's equal to r cubed plus 4r take 3. Awesome. Now rearranging all this becomes 0 equals 2r squared over 3 minus 2r. And then we can solve for that. We can solve for r there. So what we get is r equals 0 and r equals 3. Okay, so that's from this, which tells us that r equals 0 here, which is just our p value, so we know it's not that one. R equals 3 is this spot right here. Awesome. Sweet. So next thing is we know that this is now at 3, and we can sub our value of 3 in to get our y value, right? So f of 3 actually works out to be 3, okay? So this is 3, 3. Now, if this is 0, 3, that means that this line here is actually flat, all right? It's got a gradient of 0, because from 0, 3 to 3, 3, it hasn't moved up or down, it's just gone across, which means that the equation of our tangent is actually y equals 3, all right? So that's actually our first mark. Now, this seems like a lot of work for 2 marks, but that's just how it is. So, now for our area, right? Because we've got our equation for our tangent, we've got our equation for under here, now we can put those together. So the area is going to be equal to from 0 to 3, so 0 to 3, of the top equation, which is 3, minus the bottom equation, which is negative 1/3 x cubed plus 2x squared take 3x plus 3 dx. Awesome. So what we're going to get is then 3x plus x4 over 12 take 2x cubed over 3 plus 3x squared onto minus 3x from 0 to 3. Awesome. And plugging this into our calculator, we actually get 9/4 meters squared. So our total area there is 9/4 meters squared, and that actually wraps up question MM339. Guys, if you have any questions about this, as always, please hit me up in the comments below. But otherwise, thank you for watching and have an awesome day.